Definition: if two vectors are parallel, case 2. If two vectors are parallel and act in opposite direction to each other, then what will happen here? Now, if I try to move any of this vector, if I try to move it, I can move it like this. If I move it this way, angle cannot be formed here because it is head to head. But if I move it this way to this place, angle can be formed here, and that is angle 180 because angle can be formed tail to tail. So angle is 180, but 180 is pi in degree. So we are using pi. Pi in radian. Pi is 22/7 in radian approximately, or 3.142. So but in degree, pi is 180 degree. So I'll just represent it to be pi. So now angle can be formed here. So that means if two vectors act parallel and in opposite direction, as we have seen, the angle between them is pi. And note, I'm using degree here, so pi will be 180 degree. But if I'm using radian, pi will be equals to 22/7 in radian. Don't miss the 2. So but I'm using degree, so pi is 180 degree. So that means if pi is 180, then come to this place again. So that means r is equals to square root of p square plus q square plus 2pq cos 180. So cos 180 is minus 1. So that means this will become r equals to square root of p square plus q square plus 2pq brackets minus 1. So that means r is equals to square root of p square plus q square minus 2pq. So that means r is equals to square root of p square minus 2pq plus q square. So now we have this another quadratic. We have already shown the first quadratic. So if we solve this in similar way by proving that quadratic, then we'll get p minus q square, so that this will cancel out. So r will be equals to p minus q. So that is, if we solve this completely using quadratic equation, so we should not skip that since we are trying to show. So that means r is equals to square root of p square minus pq. I want to show y minus pq minus pq plus q square. So bracket it 2 2. So if we bracket it 2 2, so then this middle sign will change. If I put bracket, that will change to minus. So now r is equals to, what is common here, p minus q, then minus q, p minus q. So we'll have here r equals p minus q, another p minus q. So if we combine the two now, r equals square root of p minus q, everything square. So this will cancel out the roots. So r is equals to p minus q. Now it means in this case, if two forces are parallel and act in opposite direction, then the angle between them is pi and their resultant is p minus q. And in this case, there is a minimum resultant. So in this case, there is a minimum resultant. So in the case that they are parallel and act in the same direction, there is a maximum resultant. Take note of these points can surface in question. Now another case, which is case 3. So case 3. Case 3. So if two vectors act at 90 degree to each other, if two vectors act at 90 degrees to each other, then this will be their resultant. Alpha is the angle which the resultants make with the horizontal. So if this is vector P and this is vector Q, so now if they act at 90 degree, it means if two vectors are perpendicular line is this, and perpendicular line act at 90 degree. So if two vectors are perpendicular or act at 90 degrees to each other, then their resultant, so if you put 90 here in this theta, in that place, so or if you project, see what I'll do here, or if I project this P, remember if here is P, is the same thing as this place, so if I project it here, so it's the same thing as this place, so that means there will be a right angle here, triangle here, so and this place too will be equivalent to P. So if you use Pythagoras theorem, this is hypotenuse now, the longest side, so that means Pythagoras theorem, r squared will be equals to p square plus q square. So r will be equals to square root of p square plus q square, or you simply put 90 here, and cos 90 is 0, so everything here will be 0. It will still remain root p square plus q square anyhow you do it. So that means if two vectors are perpendicular to each other or at right angle to each other, then um, their resultant is equals to, trying to remove this back. Okay, so if two vectors are perpendicular or at right angle to each other, that means theta is equals to 90 degree. And if theta is 90, their resultant is this. Then alpha, the angle which the resultant makes with the horizontal. So if I bring the P back, and this is 90, so using Pythagoras, so tan alpha is equals to opposite, that is P over adjacent, so then alpha is tan P over Q. That is if two vectors are parallel and if two vectors are perpendicular or at right angle to each other, then R is this, and angle which the resultant make with the horizontal is this. So you have to be familiar with Pythagoras theorem here, and also SOHCAHTOA. So where S is sine, C is cos, T is tan. So sine is opposite over hypotenuse. C is cos, adjacent over hypotenuse. T is tan, opposite over adjacent. So at least these are the formulas. We also have the case if the two vectors are equal, but at least we can do that with numbers. So but for now, these are the formulas you have, and question can come on the formula. So